Hi, welcome to this lesson on Punnett squares. We're going to go over some vocabulary as well as how to fill out a Punnett square and some genotypes and phenotypes as well as some pedigree charts. Okay, so first thing first with Punnett squares, we have alleles. That is basically what it is measuring. So your alleles are your genetic code. It's the genetic probability of you having or carrying a trait, right? Now it's going to be defined, or it's going to be represented by an allele, right? So what that is there are dominant alleles and there are recessive alleles. Your dominant allele is going to be represented with a capital letter, right? And your recessive allele is going to be represented with a lowercase letter, okay? So with that, there are some things to know. So if I have two capital letters, if I have two capital A's, that is going to be dominant and dominant, which makes it homozygous is the term to know. So homozygous, meaning it's the same zygote, same allele, right? And it's the same for dominant allele. Okay, if I have a dominant and a recessive, or big letter, little letter, that means I have a heterozygous allele, right? So heterozygous is going to be one of each, okay? So now if I have two recessive alleles, that means that so it's the same. So same, we have same homozygous. But it's both recessive, so it's going to be homozygous recessive. Okay. So let's take a look at this in a Punnett square. So Punnett square, let me fit a little bigger. I'm going to have my square like this, and you'll have one parent's genes up here and the other one right here. So let's say we're measuring for hair color, right? Let's say that brown hair color is the dominant allele, right? And blonde hair color is a recessive allele, right? So let's say parent A has that gene code and parent B has that gene code, okay? First off, let's go over, actually no, let's fill this out. So in this box, I'm going to put both of these together, and it's always going to be your dominant is going to come first if I have a dominant, okay? So in this case, I'm going to bring that B in here, and the little b comes in as well. All right, so this one I have little b, little b. Now this one I have little b, big B. And this one I have little b, little b. So this one is a heterozygous. This is homozygous recessive. This one's heterozygous. This one's also homozygous recessive. Okay. Let's see what would happen if I had a parent who had two dominant genes. And then one who had a heterozygous. So here I have big B, so I'm homozygous dominant. This one, same thing, big B, homozygous dominant. Here I have big B, little b, heterozygous. And this one, I have big B, little b. So that's heterozygous as well. Now, let's get into a couple more vocabulary words. Okay. So we have genotype and we have phenotype. So, genotype is the gene itself. Okay, that's the gene code. Phenotype is the physical characteristic or physical trait. It's what you see. Okay, so let's explain that a little bit on this one. So your genotype is going to be your homozygous dominant to your heterozygous to your homozygous recessive. Let's take a look at that first square that we did. How many of these are homozygous dominant? None, right? Because none of them have 2 dominant alleles in that. So it's going to be a 0. Now, how many of these are heterozygous? I have these 2. So I have 2 that are heterozygous. And then homozygous recessive, how many do I have? I have 2 as well. So that would be my genotypic ratio, right? Now your genotype is just, am I homozygous dominant? Am I heterozygous? Am I homozygous recessive? That's what that is what is the gene pairing, right? Let's see if this other one, our second parent combo. So we have, how many homozygous dominant do I have? I have 2 that have 2 dominant alleles. How many heterozygous do I have? Awesome, I have 2. And then I have 0 homozygous recessive, right? So that's kind of how we would work out that genotypic ratio. So remember, genotype, just about the gene code itself. If we have 2 dominant, 1 big, 1 little, or 2 recessive, right? Phenotype, however, that's a physical characteristic. That's asking, do I see it? So in this case, it gives us the gene, and then it tells us the phenotype. So it says that the dominant is brown, and then the recessive is going to be blonde. So what that means is, on these kids, do I see brown hair or do I see blonde hair? Now, the rule on phenotype, okay, if I have a dominant allele anywhere, the dominant takes over, and I only see the dominant, okay? They'll carry the recessive gene, but I'm not going to see the recessive gene. Does that make sense? So in order for me to see that recessive gene, I have to have a homozygous recessive, or I have to have 2 of the recessive genes in order to see that recessive characteristic. So let's take a look at that. This square, because I have a dominant allele, that's going to be brown hair. Same with this one. This one has no dominant alleles, so it's going to be recessive, and I'm going to see that trait. I'm going to see the blonde hair. Same with this one. This one, I have 2 dominant for brown. Okay, so it's going to be brown hair. Brown hair. This one, I have a recessive gene, but because that dominant one is there, I'm not going to see the blonde hair. Okay, this is why you can see things like, have you ever heard that like ginger hair skips a generation? Typically it's because that's a recessive gene. So what that means is you have to have another parent who also carries that recessive ginger gene. And then if 2 ginger genes are together, then you'll see a ginger kid, right? So that is a little bit about Punnett squares, genotype versus phenotype. Now, on a phenotypic ratio, okay, if you're on the workbook, you'll see this on page 45, okay? is where we'll go over genotypic and phenotypic ratios, and you guys can practice that on your own. So phenotypic ratio is asking me, do I see it or not? And that's asking dominant to recessive. So let's do square one. How many dominant squares do I have? I have 2 with the dominant gene. And then how many recessive traits do I have? There are 4 here total, right? But I only see it on these 2 because these are the only 2 that have double recessive. So it's going to be 2. Okay, now let's look at the second square. So I have dominant to recessive. How many of these have the dominant allele in them? All 4, right? So I'm going to see all of this person should, all of their kids should have brown hair. Okay, there's a 0% chance that child is going to have, that any of their children are going to have blonde hair. Now, the thing about this is a random draw for every child. So it's not saying that child 1 will be brown, child 2 will be brown, child 3 will be brown. You know, that's saying that every time they have a kid, it's this probability, right? Where this person has a 50% chance of that baby being brown hair or blonde hair. So, when it asks you about percentages, each of these squares is 25%. Okay, so when I said 50%, that's because 25%, kind of like a quarter, right? How each thing is like 25 cents, right? 25%, right? So 2 of those is going to be 50. That's 50%. And 2 of those is 50. That's 50%, right? In this case, it's all dominant. So that's 100% dominant to recessive. Okay. So the big trick there is it just asking dominant to recessive, or is it asking like homozygous dominant to heterozygous to homozygous recessive, right? Okay. So we've gone over that a little bit. I'm sorry if that got a little confusing in the middle, but I hope it smoothed its way out as we got towards the end. Now these are going to be just generally, you'll be doing that on page 42 and 43, and then as well the ratios themselves are going to be on page 45. Let's go to page 44, okay, where we talk about the tracking traits in families using a pedigree chart, which is what this is called. It's basically like a family tree, okay, and this is used to track different traits. So let's assume, right, that the trait tracked is controlled by the dominant allele, right? And it's saying that everything that's colored is homozygous for this genotype. Okay, so what that's saying is that this person is homozygous dominant. So I'll just give it a letter A, okay, for allele. So that person is A, 2 big A's, right? Which means that all these other ones are also going to be 2 big A's. So sometimes these traits are shown as a color, and that just means that whatever it says in the actual like pre-question, that's going to be the trait that's being captured, that's being tracked. Okay, so if it says that the color is tracked through a color and is based on a dominant allele and it's homozygous dominant, that's what that's going to look like, right? Because otherwise I could potentially have like an A like that, but because it's not homozygous dominant, it's not going to be colored. So that just means that trait has to have 2 homozygous alleles, homozygous dominant alleles, in order for it to work. The other thing to know with pedigree charts, typically you'll have, not typically, always, a square means it's a guy, a circle means it's a girl. That's all that means. The different shapes mean. So when it drops down, that would be their kids. If it has a line that doesn't come from the line above, that means that's their spouse, so the person that they had children with, and then those are their kids. Okay. Now let's take a look at another one. Okay. So this one is measuring. So some traits are tracked through like a homozygous dominant allele. Some are tracked through a recessive allele. Okay. In this case, we're looking at tongue ties. In the case in your book, it's looking at cystic fibrosis, right? We're going to look at tongue ties though. So tongue tie basically is when in the mouth, like, let's pretend that's the tongue, right? And that's your teeth. Your tongue tie is just this little piece of skin right here, where if it goes too far up, you can't lift your tongue all the way up. That's what a tongue tie is. Okay, that's all we're measuring right here. So this trait is tracked through recessive genes, through a homozygous recessive gene. So if it's homozygous recessive, that means I'm going to have two little letters, two lowercase letters. So let's mark an X on all of these ones that have the gene. So mom here, she has it. Dad, he does not have it. He carries it though, right? Which means that there's a potential that their kids could have it. Because if we look at this, we have dad and then we have mom, right? We have big T, little t, little t, little t, big T, little t, little t, little t. Okay? There's a 50% chance that their kids could have a tongue tie because dad carries that gene. He doesn't have it. Dad doesn't have a tongue tie, but he does carry it. So there's a chance that his kids could have it too, right? Because she has it. So let's take a look. Let's look at this daughter over here. Daughter ended up drawing this lot. So she has the tongue tie, right? Because she has two recessive genes. She's homozygous recessive. But she marries somebody who is heterozygous, right? They don't have it, but they are a carrier. So let's look at their kids. Does this one have it? No, because it's not homozygous recessive. It's heterozygous. Same with this one that they married, but that person also carries it. Both of them carry it. So that kid does not have it, but this one, poor little Jimmy, does. All right, then their other kid does not have it, right? They carry it. They don't have it, though. Let's take a look at this second kid. Their son. Does he have it? No, but he carries it. And he got with somebody who carries it as well. Let's look at their kids. So their first son, he does not have it. He carries it. Second son, we have a homozygous recessive. So I have two little letters. I have two recessive alleles. So that person has it. That person has a tongue tie. This one does not, but they do carry it. And this person has this luck. So they do have a tongue tie. So it's all about probability, right? So that is another way that genes are tracked. The big thing is going to be looking through that question or that little paragraph that happens before the question that really explains what is being tracked and how you know that they have it. If it's homozygous recessive, homozygous dominant, that's going to give you a lot of insight when you come up on these questions during the test.